Hey guys, in this video I'm just going to be going over a project that I'm working on, and that's to control GPIO pins using pixel data. I originally was going to read the WS2811 or 2812 data stream coming down the pixel strings, and then take out what I need and then pass the data on, but I figured that's going to introduce lag, or it just starts to get too technical. The easier way is just to use the ICs that are already designed to do that. So what I've settled on is to read the PWM signal from the IC itself that goes to the LED. So here I've just chopped the epoxy off the end of the LED, desoldered it, and that's given me access to the three color channels, which is red, green and blue. And then I can read the duty cycle, which is the brightness, and then that will give me an on and off state. So in my opinion, that's an easier way to go about it, and it won't introduce lag into the system. You can also take the ICs off and remove the bullet pixel part altogether, and then use like 1.27mm spacing breakout boards, and then just solder the ICs to them like that, which I've done in another example. And then that should give us the ability to read pixel data and then translate that into something like a relay switch or whatever it may be. So the whole idea here is I want to be able to plug it in anywhere along a pixel string with props before or after it, and it not affect anything else in the chain. And that's why I kind of went with the ICs. And as you see here, the whole idea is you just plug it in, there's your pigtail, you have your LED, which could indicate a prop, and then I've soldered 3 wires which go to an Arduino Nano to read the PWM signal, and then the data can pass out to the next prop. You can have a pigtail or whatnot on it. All the power needed can be taken from the pixel string itself, whether it be 12 volt or 5 volt. You just obviously you want to make sure your relays are 12 or 5 depending on your voltage. That's fairly simple. And then you can control motors or whatnot, relays. But anyway, this is the first simple setup that I've got going, which is this is just like think of it as a pixel string coming from a controller. So I've got a LED switch so you can see what's going on, and then this could be a pixel string, and then string on to the next one, whatnot. So the idea here is that you can plug it in anywhere. If you're running a 12 volt system, obviously you want to use a voltage regulator to step down for the 5 volt of the Arduino board. And you can use 12 and 5 volt relays. So the whole thing could be powered off just the pixel string itself, no remote power required. This little example here basically gives me 3 relays. I can go a 4th if I want to use the white channel, but just in this one I'm just going to go the 3 different colors, which will be the red, green and blue channels. And yeah, so I've just got a simple 4 relay board here. This has optical isolation, and it's kind of the easiest way to do this. It's got diodes to stop kickback from the coils and all the rest of it. So, for a pre-made board, that's the best way to go, honestly, when you want to use relays. And then just the Arduino Nano. You could use ESPs, multiple different types of boards. As long as the MCU on it is modern enough to handle the speed, you should be fine. In X-Lights, this is how you would control it. So you've got your red, green and blue channels, and like I mentioned before, you've got a white channel. So this can turn all 3 relays on and off, or it can be used as a 4th channel. So you can have 4 relays, that's entirely up to you. In the Arduino code, it's fairly simple. You just have your PWM pins and then your relay pins. I have a relay white, but I'm not using it in this example. It's just there because why not? And then you set up, so we're setting the pins to be pulled up, and then output pins for the relays, and then you just run through reading the PWM here and flicking the relays. You could operate servos, whatever you really want. It's a trigger point. It's very simple to control. All we're looking for is the brightness. So here we go. Here we've got, this is the on and then the off. And all I'm doing is switching the brightness for that channel. So I've got brightness 100 and then brightness 10. So that's a good variance between the two to be able to switch them on and off. So we'll turn it on the output to the controller, and as you'll see, the red channel is lit up red, so that's on and then off, and then green and then off. Yep, blue and then off. So it's fairly simple. You can have all three on with white, and then all three off. And then these colours here, you can switch 2 different relays on, depending on the RGB values. And you'll see, yeah, so you can just hit play and it'll go through. So it's fairly simple to control. So you could set this up however you like in your sequences, and all it is just a single line. So I've just done a single line with 1 pixel because we're only controlling 1 pixel here. So I've got the 1 pixel there and then the other one for the LED, so you can actually see what's going on. And then these here, this is for the multi-board that I'll show you in a second. So okay, this one here is a little bit different. I've soldered 3 of the ICs. So I've taken 3 of the ICs here and I've soldered them onto a SO28 pin breakout board. So there's 3 of them in there, which you'll see in the GitHub repo. All of the wiring in for this is in the GitHub repo. And what this basically does is this gives me 3 pixels worth. So I can drive this 8-channel board. It's basically the same idea as the other example, but it just gives me more outputs. And yeah, it's the same thing. With this, the data comes in, and then you're looping it into the next chip, data out, data in, data out, data in. On each input you want to put a 33 ohm resistor, but I haven't got that here because I'm just testing. The spec sheet says you want a 33 ohm resistor to stop reflections, so data bouncing around, whatnot, causing issues. So in the wiring diagram it has it, but here it doesn't. This is good enough for a test anyway. And then with this one, as you see in X-Lights, we've got 3 channels. So I've got channel 1, 2, 3. That just represents the pixels, and it's the same thing. So if we enable the output, we've got red, and then green, and then blue. And then the next channels will be red, green, blue. And then the next channel's red and green. And I don't have a 9th relay because it's only 8 on the board. But blue would be the 9th relay. And yeah, that's the same thing, you can play it. In this example, you'll actually see the GPIO I've connected it up to, which will be this one. That one there, that's the blue channel, the last blue channel, just so I know it's working. And that'll flick that LED off and on. And yeah, this is the same as the other one, except for you just got more pins. So your PWM pins, your relay pins, your brightness threshold. I haven't bothered with the white channel here. You could if you wanted to, but I haven't bothered with that. And then, yeah, it's pretty much the same as the other code. Everything seems to, run fairly good. Obviously, I have to do more testing. I will update the repo if I have any issues that pop up when I actually go to use this. But the season's winding down, and I figured I'd just do this before I, stick everything away and trash the dud LEDs that are sitting on the bench. It's a good way to make use of some old LEDs. Now I know that you can buy like pixel to relays and pre-made stuff. You can use pies and all of that. But as I said, I wanted I wanted a solution that would plug into a pixel string and be able to provide a relay or a servo motor or whatever it may be at that point without needing a Raspberry Pi or, you know, to run extra network cables or, you know, Wi-Fi, whatever it may be. This basically just gives you pixel data to something physical. So I could trigger smoke machines or, you know, snow machines or whatever like that. You could, at the start of a sequence, like at your start of the show or the night, you could use it to trigger things to switch them on, like tune 2 signs or whatnot. And then once the show's finished playing, the final sequence can be the switch off sequence. So, you know, instead of running smart plugs and all of that, you could use something like this to simply just use pixel data. It's a fairly simple take on pixel data, and like I said before, with this, you would just have your pixel data come in, and then you run it through each chip, and then the pixel data comes out to the pigtail to continue down. And the good thing about doing this instead of messing around with the actual pixel data coming through the stream is that we're not going to slow anything down in the Arduino, so it's not going to cause stuttering or lag. As far as these chips are concerned, they're outputting to a LED, and regardless of what this is doing, it's still going to continue to pass the data through the ICs, and that's kind of why I figured this is probably the better way to do this instead of messing around with trying to decode the data, take bits out, and then send it on down the stream and all of that.